Okay, next, let's do joint 8. Eight. Let's see, what are we going to draw the point first. We have RB going up and M. There's P. There's K. And there's L. Okay, what do I know? Well, I know that P is in compression. Draw like one. I know M is also in compression. That for now. So sum of the forces in the y direction equals 0 is equal to RB minus M. And then we've got this diagonal K. So I know there's going to be a KY. And let's see, let's guess here. RB is going up, M's going down. I'm not sure which way K is going to be, but I will guess that it's in tension. Um, and yeah, so that would mean that it's going up in the y direction. So plus KY. So we can substitute in. We know that RB is 6.66 K minus M, which is 4K plus KY. I can say 0 is equal to 2.66K plus KY, which would mean that KY is equal to negative 2.66 kips. Okay, I got a negative answer. That means that my assumption was incorrect. My assumption was that K was in tension, so therefore it is in pressure. I'm trying to change the direction. Okay. Okay, it's in pressure. Okay, so now sum of the forces in the, oh, darn it, I did it again. I boxed KY, but I really need to find K. So KY is equal to negative 2.66 K. All right, so let's do the triangle for K. K, KY, KX. And because it's 45 degrees, I can say KX is equal to KY is equal to 2.66K. To get K, I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared, which is KX squared plus KY squared equal to K squared. 2.66 squared is 2.66 squared K squared. Then 0.1 plus 7.1 K equals k squared. K is equal to the square root of 14.2. K is equal to 3.76. Okay. And I know from before that it was in compression. So this is the one I've been in box, not KY. Okay. Okay, so we got K. So now we can say sum of the forces in the x direction are equal to 0. And we've got 0 is equal to, I see negative P, it's gone to the left. I've got K, which is going to the right. So I can say plus KX. And then I've got L. I don't know which way L is going to go. But I'm gonna guess that maybe it's compression. So I'm gonna say plus L going that way to the right. Okay, so I can say 0 is equal to negative P. P is 2K, negative 2K plus KX is 2.66K plus L. And that would be 0 is equal to 0.66K plus L. So L is equal to negative 0.66. Okay. All right, I got a negative answer for L, which means that my assumption was wrong. My assumption was that L was in compression, but since it's wrong, I know that it's going to be actually in tension. So it's going to be pointing towards the left. Okay, got that. So now we can come back to joint 5 because now we've got some more answers this time, so we're ready for it. So let's come and say joint 5. Let's see what we got. We got 2K going down. We've got I, got F, got J, G, got K. All right, let's see what we know. So looking over here, I can see that I know that F is in compression. So this F is in compression. I can see that G is in tension. I can see that K is in compression. And I can see that J is in tension. Okay, so let's do sum of the forces in the y direction equal to 0. equal to, let's see, negative 2k plus ky going up minus gy, because gy is pulling down, minus gy. And then we've got I. And I don't know if I is, which way I is going. I'm going to assume that it's in compression, but we'll see. So I'm going to say plus I. All right, I can say 0 is equal to negative 2k plus, let's see, what's ky? Ky is 2.66k minus gy, which is 0.66k plus I. So I can say 0 is equal to, look at this. If I add up 2k, negative 2k, and positive 2.66k and negative 0.66k, I get 0 plus I. So therefore, I is equal to 0, and it's in either tension or compression. Okay. And then at this point, I have all of the members, but I'm going to check 0.6 just to be sure that everything adds up. So I'm going to say 0.6, and we've got I, and we've got H and L. So I know that H is in tension. And I know that L is in tension. And I is 0. So let's just double check. Sum of the forces in the y direction equal to 0 are equal to I. There's just I. So and I equals 0. So we're good. Sum of the forces in the x direction are equal to 0, equal to L minus H. They're acting in opposite directions. And I know that L is 0.66. And I know that H is 0.66. So 0.66 minus 0.66 is equal to 0. So we're good. Checks out. Okay. That was how I went through and solved the forces on this truss. I hope this was helpful. Uh, Send me an email if you have any questions.